Okay, cool. Okay, I think that's everyone. So let's just get started. This is just like a review of some of the stuff that we've went over for Kotlin. And yeah, let's see how it goes. Let me see if I can turn the volume on as well. Um, all right, let's get started. Uh, okay, advantages of using a database. We're gonna go over this more today as well, but try to see if you can figure out what it is. Yeah. Okay. I like to be really tricky in my in my Kahoot questions. Everyone knows that. All right. So yeah, maybe this wasn't as much of a review, but it's gonna give a bit of foreshadowing to what we're gonna talk about today. So actually they're not faster to compile than regular classes. I just made that up. It's the same speed. They also don't really like intelligently generate special extension functions like that does those words. I kind of just threw them together. Um, so yeah, I wouldn't really say that either. But we do have our constructors, getters, and setters are all generated for you. That is true. So yeah, I like to be tricky because I feel like every time you see a multiple choice, like always all the above. I want to have one that's not all of the above. So yeah, leaderboard is gonna stay stagnant for this one. Okay, this one should possibly be a little bit easier. Yes. Okay. Everyone got that. Perfect. Yeah. So that is true. And this is a topic called higher order functions, which we're going to dive into a bit deeper today. Okay. See if anyone remembers what the question mark does. Okay. Yeah. So a good amount of us got it. So it returns. So in this case, it would return null if my list is null. And otherwise, it would call the function that you put inside of that, or actually that you put after the question mark. So dot for each is something called an extension function, which we're going to learn more about today. And that would be called if my list is non-null. And then whatever the result of that function call is, that would be the value that that takes on. So for other function calls, they might have different results, but question mark dot will return null if the object is null, and otherwise it will call the function. Yeah. Okay. And our last question, how is the hack challenge going? Little survey. Okay, awesome. So no one's having trouble, it seems. Everyone's making progress. All right, that's awesome. Yeah. Okay, cool. So let's just jump right into the lecture then. Um, yeah, so I decided to go with like a bit of a different template today. Yeah, this is the beauty of Kotlin. Why Kotlin is my favorite programming language. So I think I've like said this a lot throughout the course, like how much I love Kotlin, and I always make like I made like some I like making Kahoot questions on it and stuff like that. So this is just my lecture. I get to talk about why Kotlin is so great, and I think it's really going to give you like a lower level like understanding of what our code is actually doing. Like I think it's pretty easy to sort of gloss over the syntax and sometimes just like copy paste things that you see from the textbook and add modifications, and that works, right? But I think you can really become like a better developer and have a really like a way better understanding of what you do when you really understand like what's going on behind the scenes, right? So just giving like a bit more information on the Kotlin programming language. So let's get started. So why do I love Kotlin, right? And no, it's not just because they have a cute mascot. They have a lot of like really incredible features, and I'm going to go over just a few of them in today's lecture, but there are more reasons why I think Kotlin is the best programming language. But again, I do want to emphasize that is opinionated, and it's the best to me, it's the best programming language that I've tried. I'm not saying it's like objectively the best one, but yeah, let's get into like what makes Kotlin so special. So there's like three main features that makes it a really powerful language is the first feature is higher order function support, right? That ability to pass functions as arguments to other functions. And there's functional programming languages which allow you to do this, but the special thing about Kotlin is that it's both object oriented and functional, which just makes it really powerful. So yeah, that's a really good feature. The next one is extension functions. So I'm gonna get more into like what this is when we get to it, but yeah, it's just another great feature. And also the concise syntax. Kotlin has like a lot of built-in features that make your code way more concise. We can go from like 10 lines to just 1 using Kotlin. So it makes the syntax really concise and really readable. All right. So let's start off with higher order functions. So what are they? How can we use them, right? So higher order functions basically allow functions to be passed into other functions. It makes for a far more concise syntax, and it really just like powers up your code to the next level. So let's talk about some examples of higher order functions. And some of this stuff we've already seen, some of it's not, but I'm going to show you like a really interesting function that Kotlin has built into the standard library, which is called repeat, right? So if you might be familiar with like your Kotlin for loop, right, where you put like for this many times and then you specify the code that you want to be executed. But the interesting thing about repeat is that like when a for loop is processed by the compiler, the for loop is a very special thing in a programming language, right? Because it can execute code numerous times. But Kotlin, when we use the keyword repeat, what we can do is we can actually we can pass in a function, and this function will just get executed 10 times, right? So we're able to pass in a function with these curly braces and just execute the code over again. And as opposed to like Java, where you would have to pass in an object that implements a certain method from an interface, right? Which is a lot more convoluted. With Kotlin, you can just pass in the function exactly. And you can also specify the parameters of the function. So in this case, my repeat function, repeat is a function that takes in 2 arguments. So the first is the number of times that you want to repeat. That is an integer, right? So in this case, I said 10. And then the second argument that it takes is a function. And this function has the parameter of index. So I basically need to create a function that says, okay, when I'm given an index, this is what I want to do with it. And I print that index. So you can sort of think of this as like a for loop going from 0 to 9 inclusive. And we're essentially like printing out all the numbers. But the key takeaway here is that by using these curly braces, we're not just writing code that the compiler interprets, we're actually passing in a function. And that function specifies how do we want to handle this index. Does that make sense to everyone? Does anyone have any questions on that? Okay. Yeah, so this is just showing like the equivalent function that you might have. So like this is a function called int printer, and it prints the index. So I mainly have this to emphasize like the functional nature of what we're doing here. So this function could actually be rewritten as just passing int printer in to repeat as the second argument, right? So this syntax with the curly braces is actually just shorthand for essentially creating this int printer function and then passing it in as the second argument of repeat. Okay, so yeah, and then one more other thing about function, like the way that we can pass in functions is that we have this print and then we use it, right? So it is actually a keyword which basically represents the index parameter. So it is like it's a special keyword that you can use, and you can only use it when the function that you're passing in has 1 parameter. So in this case, I need to specify a function such as int printer, right? That specifies how am I going to handle this index, right? So I need to show how I'm going to handle the index, but I don't actually have to give the index a name. Because there's only 1 parameter, I can just call that parameter it, and then I can access it inside of the function. So this is really no different than this. Like these are basically like you're still passing in the int printer function. It's just that we're using the keyword it, so we don't have to actually write what the parameters are. Does that make sense to everyone? Okay, awesome. Okay, so now we're going to go over like a little bit more of an advanced use of higher order functions, which is called, so there's this function called filter. And filter basically takes in a function that has an integer as its parameter and returns a Boolean. So whenever we have like a function like this that takes in something as a parameter and return a Boolean, we usually call it a predicate function. So in this case, filter takes in a predicate function as its argument. And what does this predicate function do? It says it greater than 5. So it will return true if the number is greater than 5 and false otherwise. And what this filter function does is that it runs this predicate on every element of the list, and then it will essentially only add to, or it will basically take the elements from the list that satisfy that predicate. So here we only want the elements greater than 5, and we have 6, 8, and 10, right? That's what this program would output. So yeah, this is another example of how we're actually passing in a function. We're passing in a function as an argument, and then the code is running that function for us. And this can make for some like really powerful coding techniques, such as this filter. So yeah, another important method is map. So here we pass in a transformation function. So this transformation function, it takes an integer and then it provides an integer. And we apply this transformation function to every element in our list. And then the resulting list is just like our previous list with every element transformed from this transformation function that we pass in to map. So that's another important higher order function. And another really cool thing that we can do is actually compose these functions. So we could first map my list to like a bunch of like an incremented version of itself, and then we could apply this filter. So does anyone know like what values would special list contain? Values or value? What do you think? Yeah. Yeah, that's right. So that's why I said values or value. So it would just be 2. And the reason is we take map. So first we increment each value in the list by 1. And then we check, okay, it mod 2 equals 0, which is saying, okay, is the value even, right? So yeah, after we increment each one and then check if it's even, the only even left will be 2, which is just like 1 incremented by 1. So yeah, that's how that works. Yeah, and another thing I want to note is that like in a typical programming language where you don't have access to these higher order functions, right? You would have to create a for loop, and you'd have to go through each index of the list. You would have to increment it, and then maybe you would do a whole nother for loop just to filter the list. But in here, we can just do it in like just 2 lines. So yeah. Okay, and then there's also .for each, right? And this is another like functional substitution to a common thing that we see in programming, which is this for each loop to go through each element of a list, right? But instead, we can actually use .for each and pass in a function, which is just the action that we want to perform on every list element. And the cool thing about this function is that it's actually a lot faster than using a traditional for each loop. So when you have a collection, such as my list, like any collection in Kotlin, for each will be faster. On int ranges, which is kind of specific, it will be a bit slower. So technically, you shouldn't always use it. I do want to throw that out there, but typically for each is faster, and it's using this idea of functional programming. Okay. Yeah, and then there's also this other method called for each index. And I included this to show an example of what happens when we have a function that has multiple parameters. So here we're passing in a function that says, okay, I have an index and an item, and what do I want to do with this, right? So it's printing it, and the way that we like pass in a function that takes multiple parameters is we separate the parameters by a comma and then put this little arrow. So I'm using a special font, but that's actually just a dash and then a greater than sign. So yeah. Okay, so just a summary of what we went over, right? So we can pass functions as arguments to other functions. The it keyword is the implicit function parameter. So instead of specifying the parameter name and then putting the arrow, it works when there's only one parameter a function takes in. And methods like filter and map tend to be very useful in Android development. For example, when you have data from a backend and you only want like certain parts of it, right? You can use filter and map. It's extremely useful. So yeah, does anyone have any questions at all on this? Because this topic is like a prerequisite for the next one. So okay, cool. So now let's go into extension functions. So what are extension functions? They allow us to add functions to a class that we cannot modify. And I think this will become a bit more clear when I show an example. It lets our code be a lot more reusable, and it's also essential knowledge for Jetpack Compose development, and I'll get into why that is later. So yeah, let's talk about some examples, and in fact, we've already seen some. So first, I'm just going to do like a very simple example, which is this starts with K method, right? So what this does is you can see that the syntax is a bit weird. This takes a bit of getting used to. I even still have to search up like what is the syntax for extension functions when I implement them because it feels a bit unintuitive. So you start with the word fun because you're defining a function, and then you type the name of the class that you want to create a function for, right? So the string class is already implemented for us. We can't actually modify the string class, but extension functions allow us to define a new function for the string class. So in this case, it is the starts with K function, and it returns a Boolean. So, and basically the way that this actually works is we have a string, and the string is actually stored in the this keyword. So it's a little bit different. It's a little bit different than like higher order functions where it's in it. Instead, when you define a function for a class, right, it's actually going to use the this keyword. And if you've like implemented a class before, you're familiar with the this keyword, which represents like the current object. And we just check, does it start with K? So that's a more basic example. And in terms of like how you would use that, right, is that you could put like in quotes, no, right? Like the word no in quotes, and then you could put a dot after the quotes, and it would let you use that function. Even though it's not an official string function, it would let you use it. So that's like sort of the power of extension functions. Here's another one. So the complexity of these gets a bit higher now. So here we have a generic list of type T. So basically the idea is I want to be able to check if a list is null or empty with like one simple function, right? And I want to be able to reuse this throughout my code. But the thing is that I don't know what type the list will be. I don't know if it's a list of strings. I don't know if it's a list of ints, right? I just have a list of data and I want to check if it's null or empty. And I think you would be able to see how this function could be useful in the real world, right? So I have this function I want to implement, but I don't know what type the list is going to be. So the way that I like essentially get around that is by using this T. So whenever you have a function on a class that has a parameterized type, which basically just means like I'm passing in a type to this class, and the behavior of this class depends on like what type I have in there, right? So if it's a generic type, you have to write T in those like braces right before the class name, and then you have list of T. So it's kind of, again, the syntax is weird. Like if you have to look this up, that's totally fine. But that's the starting thing. And then because the list is nullable, I put a question mark at the end. So question mark dot is null or empty. And then the actual code of the function is pretty simple, right? So I just check if it's null, then I return true. It is null or empty, right? And if it's not null, then I can just directly call the dot is empty function. And this will get smart cast to a non-null list because we already checked if it's null. So yeah, so that's another example of an extension function. And here's another one. So filter is actually an extension function. This function that we've already looked at is an extension function on the list class, right? Because with any list, we can type dot filter and we can filter through those items. And here, this is actually the implementation that Kotlin uses, or Kotlin's implementation might be slightly different. But I actually looked at the code that Kotlin implements and like basically put like a slightly more like basic version of it. So essentially, if you look at this, I think the most interesting thing about this is the type of the parameter. So you can see the type is t arrow boolean, which means that the predicate function, right? So t is the type of the elements in the list, and the predicate function takes in a list element t and returns a boolean, right? And the code itself is actually not too bad. So we basically just loop through each element of the list, check if the predicate satisfies it, and you can see here we're using it, the it keyword for each element of the list. And if it does satisfy the predicate, then we add it to our result, and then we just return our result. So that's essentially how that works. Yeah, this was like a more complicated extension function. Anyone have any questions on this? Okay. And here's why extension functions are useful for Jetpack Compose. I'm sure there are many other reasons, but I just want to highlight one reason that I came across as I was working on volume. So we have our modifier, and a modifier is a class that's built by Kotlin, or sorry, built by whoever made Jetpack Compose. I think Google. So it's built by Google, right? And we can't actually modify this modifier class. The implementation would be like pretty difficult to modify, right? So, but we still want to add our own custom modifiers. So, for example, like if you remember, what are modifiers used for in Jetpack Compose? We went over this like a while ago. I want to see if anyone can recall. And you might be able to get like an idea from this image here. Yeah. Yeah. So it changes the layout and it also adds styling. So you can sort of think of modifiers as like the CSS of Compose. They essentially allow us to add styles and change the layout of our app. So now let's say I want to add a custom modifier. So what I actually did, this is in the volume code base, is that I declared an extension function. So I said fun modifier.shimmer effect. So I'm declaring this new function for the modifier class without actually modifying the modifier class, right? So I declare this new function, and don't worry about the code inside of it. It's just like some Jetpack Compose stuff with making an animation. But the cool thing about this is if you've seen that like shimmer effect when things are loading, right? Where it has that little animation, and it's usually like a gray box and has that animation as it's loading. So this extension function actually allows me to apply that animation to any modifier with just one line, just using .shimmer effect. So you can see how creating custom modifiers can be really powerful. And the way that we do that is essentially derived from this like lower level concept called extension functions. So yeah, we can add functions to classes, right? The wait, let's see. Yeah, okay. Yeah, so the summary, that was actually supposed to be for the other one. Sorry. I missed that, but I can just summarize it right now. So, yeah, we can add these functions to classes that we can't directly modify, right? And it's actually the this keyword. Sorry, don't pay attention to the slides. My bad. It's actually the this keyword that we use to figure out like what object are we dealing with inside the body of our extension functions. And yeah, we can use modifiers and stuff like that. We can this really powerful concept that allows us to reuse our code. So okay, let's try it yourself. So if you installed IntelliJ IDEA, that's great. If you haven't, you can just look up Kotlin Playground on Google, and it will give you a like web interface to play around with the programming language. So try creating an extension function on the class list of int, and we're going to call this extension function only evens. So it should return true if the list has all even numbers and false otherwise. Yeah, feel free to like use the extension function that we discussed in class to help you. And yeah, look up the syntax for extension functions if you've forgotten. So yeah, I'm gonna give I'm just gonna let everyone work, and then we'll see how we're doing in a few minutes. So just try that out. Let me know if you like don't know where to start or need help. And just as a reminder of the syntax, because I know it's very easy to forget for extension functions. You type fun, and then the class name, and then a dot, right? And then you type the name of your function and the parameters, and you define your function. So. I'm going to do it as well. All right, give me like a thumb status, depending on how far you are. Okay. It's like some of us are reasonably far. I'll give it a little bit more time. It's definitely going to be a lot harder if you're using the playground because you don't get like the syntax highlighting. That can really make things a lot easier. Um, so Yeah, I want to make sure we have a good amount of time for the next example as well. So I'm going to show the solution. Oh wait, right. Okay, yeah. I remember I did actually purposely did not put in a solution for this one. However, I did put the code in Kotlin Playground, so I'm going to show everyone that. Okay, so yeah, this is the code. We're basically putting in, oops, sorry, trying to zoom in for everyone. Okay, so what we have here is we have a function, right? So first the class name, so list of int, I gave that to you, right? Dot, and we put the name of our extension function. So this should make like some sense, right? Because we have this dot, and we're going to call this on list of ints. So dot only evens. And this is the part that I feel like some of you may have missed because we didn't actually show an example of an extension function that returns a value. So when you have a function returning a value like this, you're going to need the type of the returned value. So this is a colon boolean. This says the type of this function is going to be boolean. And the way you can do that is using these extension functions. So I'm using the for each extension function here. You didn't have to implement it exactly like this. You could have used a traditional for loop if you want. But again, just showing like the power of these functions that Kotlin allows us to make this concise syntax, right? So if it mod 2 does not equal 0, so if the number is odd, we say return false. The list does not only have evens. And then if we get to the end and we haven't returned false, well, the list only has evens, so we can return true. Anyone have any questions about this implementation? Okay, so now we're going to have a bit of a harder example. So this next one is we're going to basically be combining these two ideas, the idea of a higher order function and an extension function. And the way we're going to combine these ideas is by creating an extension function that takes in a function as its argument. So we're combining what we've gone through in lecture so far. So we're going to create an extension function on the class list of t. And remember, there's a special thing you have to do with the syntax when you have a parameterized type. And this extension function is going to be called all, and it will return true if all values satisfy the predicate function, which the user passes in, and it will return false otherwise. And I put the function's type below as a hint. So this is what the type of your function should be. It should be, it should take a predicate, which is of type t arrow boolean, right? So it takes a thing from our list and returns true or false. But then this entire function should return true or false, right? And I think all of you can see how a function like this could be really useful. So instead of having to write the code to go through a for loop, right, and do what we did before, where we had a for loop and we checked if every function matches the predicate, which was only evens, right, then we return true. But with this extension function, we wouldn't even have to do that. We just have to pass in the predicate and it would do all the work for us. So yeah, being able to code like this is really, really important. Makes your code really concise. So definitely give this one a shot. I'm going to give everyone till 9:15 because I do want to make sure I have time for the third feature. So hopefully that's enough time. Try your best. See what you can do. Okay. I'm going to start going over the solution now. So hopefully that was a good amount of time to at least get started. If you want more practice with this kind of stuff, you can definitely implement it in your hack challenge. Like these general Kotlin concepts are really applicable to writing like clean code. So definitely like experiment with this in your hack challenge. But for now, here's the solution. So what we have is, I think this first line is probably the hardest because there's like, the syntax is just pretty weird, right? So we have this t, like fun t list t dot all predicate t arrow boolean colon boolean. Does anyone want to try to explain like what this first line means? Yeah. Yeah, exactly. Yeah. So it takes in this other function, right? And specifically, this is an extension function on a list. So that's another key point. But yeah, that's basically it, right? So that's what that's doing. And then we have our this dot for each. So we go through each one, we see, okay, if it doesn't satisfy the predicate, return false, otherwise return true. So you can see this is actually a more generic version of our only evens function, right? It's pretty cool. So we can go back up here and run, and you can see that I basically made that, I'm using the all function to make the only evens function with basically just one line. So my predicate here is if it mod 2 is 0. So if it is even, right? So I'm checking, is all of the values even? And in this case, it's true. And here's another implementation that is a bit more concise, but I want to show this 1 second. So we can use the extension functions that Kotlin provides to do this in just a single line. So remember the argument for our filter function, right? Our filter function takes in a predicate function. So what we can do is say, okay, if my list is equal to, if my list is the same after I apply this filter, then that means that all elements must satisfy that filter, right? So you can do this in a single line of code. That's another really cool thing. And I actually, that's fine. So anyone have like any questions on the main implementation or this like more concise version? Okay. So in that case, we'll get back to the final part of the presentation. Yeah, there's the solution. Okay, so the final part of today's bonus lecture is the concise syntax of Kotlin. So I already showed you a little teaser of that with just using filter to do it in one line. But yeah, there's various features of Kotlin that allow the syntax to be far more concise. And we'll go over each one of these. So let's start with this function, right? So our is null or empty. So I showed this implementation earlier, and I feel like this one is a bit more readable. It's pretty easy to see what's going on here, right? If it's null, we return true. Otherwise, we return if it's empty. But we can actually turn this into one line. And here's the single line implementation. So remember at the beginning of the Kahoot, we talked about how the question mark operator will return null if the value is null, and otherwise execute the function, right? So basically, if this is null, what's going to happen? Well, question mark dot is empty will return null. And then question mark colon says that if the value on my left side is null, then I will return the value on my right side. So basically, if this is null, then this question mark dot is empty will be null, which means that this question mark colon operator will evaluate to what's on the right side, which is true, right? And if this is not null, then it just becomes this dot is empty. So yeah, that's just like one way how we can make things more concise. And this is using the Kotlin concept of nullability, which I chose not to dive into because I feel like you get a good amount of experience from this with Android. But I just wanted to show, like, you try to be thinking like this when you create functions. How can you make it like as concise as possible, right? Yeah. Okay, and this one I actually already showed. So this was just turning the all function and applying the filter function to make it one line. Yeah. Oh, and then here's like another thing of syntactic sugar that Kotlin supports, which is that when you have a function like this, right? So you have a function that just returns a single value, and that's all it does. You can actually just say, oh, well, my function's value is equal to the value. So notice how I don't have return, I don't have curly braces. I'm just sort of directly saying like the result of this function is equal to what I have down there, right? So it's just another way, like Kotlin supports a ton of these types of, they're called syntactic sugar, where we basically take something that is like a bit more complicated in the syntax and reduce the syntax to something a lot simpler. And Kotlin has tons of these. So I'm just going over like a few different ones. Here's another one. So let's say you want to get the first 3 elements of a list, and you have you might want to like instantiate these as values. So here the implementer says, okay, I'll say val first equals the first element, val second, right? And that takes up like 3 whole lines, and it kind of feels a bit like verbose, right? Like, don't we wish there's something that we could just do that would get us the first 3 elements of the list really easily? And in fact, there is. So this is called pattern matching. So what happens here is Kotlin recognizes these parentheses and the commas. And what that means is basically Kotlin looks on the right-hand side, and thankfully, the language is really smart. So it figures out, okay, this is a list, and I have these parentheses and commas, right? So I'm going to assign the first element to the first value of the list, second element to the second value of the list, third element to the third, right? And this is basically just took what we did before, but now it made it a single line, and it's even more readable than before, which is really cool. And another thing about this is that this general like pattern where you take an object that's like kind of complicated, and we get we like create variables that represent different parts of the object. That's called object deconstruction. Deconstruction. So if you've like used JavaScript, you might be a bit familiar with this, but it's really cool that Kotlin also has support for this idea. So yeah, and the other great thing about this is this is not exclusive to list. So you can actually do this with the pair class as well. Kotlin has a pair class that just represents a pair of 2 values. So you get like first comma second is equal to the pair, right? And I'm sure you can do this with other iterable classes as well. So that's just a cool piece of syntactic sugar I wanted to share with you all. Another one is the when statement. So you don't see it here. This is our previous code, which is pretty verbose, right? So we take this color, and we're trying to implement parse color, right? So we saw that a little bit in the homework, but let's say we're Google and we want to implement this function. So this is like the more naive implementation where you run an if statement for every possible color. So if parse color is red, if it's green, if it's blue, then we have all these separate return statements, all these separate curly braces. And then otherwise, if it's none of them, we just like throw an illegal argument exception. We say we can't take this argument, right? But here's the cool thing is that Kotlin has a way that we can substitute. Instead of having to write a bunch of if statements and some like giant if chain, we can actually use a when statement. And this again like covers the idea of pattern matching. So we say when, then we pass in the value that we want, right? And then we like sort of reuse that arrow syntax. So remember, that's just a dash and then a greater than sign. But basically the idea is we put each value, so like red and then an arrow, and then we say, what do we want to do? So if it's red, I want to return a triple that just represents like the RGB value, right? If it's green, I want to return that triple. If it's blue, I want to return that triple. And else, if it's any other value, I want to throw an illegal argument exception. So the when statement is really useful for just creating like very clean and much more readable code. So if we look at the difference between here, where we have all these curly braces, we have, if you're reading this, right, you're going to have to look at each if statement individually. And it takes more time to read as opposed to if you just have this when statement, you can really easily see when it's red, I want to do this. When it's green, I want to do this. When it's blue, I want to do this, right? So yeah, it's just like beautiful that like Kotlin, allows us to do so many different things like this to make our code much more readable, much more concise, right? And just much more effective. So yeah, and the last example might run a couple minutes over, but we're nearly there. So the last example is our dog class. So here we have this like dog class that's like sort of like naively implemented, right? Where it has a name and it has a barking noise, and that's how we construct a dog, right? So when we initialize the dog, we set the name and the barking noise. And then the dog has these special methods. So we can compare dogs to other dogs using like an equals, right? And we have to override that function. And same thing with hash code, right? So maybe you might not know too much about hashing, but if we want like a unique code for the dog, right? We have to implement that function ourselves based on the way that based on like the parameters of the dog. So obviously this is a bunch of code, and in Java, right, you would have to implement all the getters, all the setters, etc. So this isn't even the full implementation of the class traditionally, right? So Kotlin allows us to be far more concise, and I'll show you what we can do. A data class, right? So look at this. This could fit into a single line of code. I chose to have it span multiple lines, so it takes up more of the slide, but this could really could just fit into a single line of code, right? So we have data class dog, and it has a barking noise and a name, and that's it. We just specify those parameters. And the thing is that these other methods, right, like equals and hash code, these will be generated for us by Kotlin. So this equals method, right, it will just by default compare every parameter of the data class. And this hash code, that also gets generated for us, right? So we don't even have to implement this. We don't have to implement the constructor where we set up the name, right? Data class does it all for us. So data class is a little bit more restrictive than regular classes in terms of like what we're able to specify about the class. But in like most scenarios, a data class can do the things that you need a class to do, right? So yeah, it's really powerful for like creating objects, basic objects like this. So yeah, okay, just to summarize, right, why I love Kotlin so much, and I hope now you do it too. It supports higher order functions, extension functions, and concise syntax, all things that make the development experience just so much better. And among other amazing features, such as coroutines, smart casting, a very robust standard library, null safety. Unfortunately, I don't have time to dive into all of these topics, but definitely like look into this on your own, especially coroutines. That's really important for Android development, but it is a bit too advanced for like a 50-minute lecture. So yeah, that's all. Thank you. Yeah, thanks for coming. Even though attendance was optional, it's great to have people here. So that's about it.